Today we are going to continue our exploration of simplifying rational expressions. But however, today we're going to add something to it. Not only will we be simplifying rational expressions, but we will also be multiplying them and dividing them. So if you could take out your Cornell note sheet and write down your know and do, go ahead and pause it at this moment. Our know today is to multiply and divide rational expression, and when you're all done today, you're going to be able to simplify something like this. Okay, go ahead and pause it. Here are two questions. Let's do them as a warm-up today to review what we did last class period. Go ahead and pause it for a few minutes and work through these two questions. Okay, now that you've worked through those two questions, let's go ahead and look at them to see how you did. On the very first one, your answer should have been this right here, x minus 1 over x plus 1. And when you set the denominator equal to 0 and you solved it, you found that x was not equal to negative 2 and a 5. For the second one, you had to put it in descending order first, and then you factored out that negative x. So when you were all done, you got negative x over top of x minus 1, and when you set the denominator equal to 0 and you solved it, you found that x could not equal 1 or 6. Alright, let's move on. Okay, looking at the first one here, you're going to see a monomial divided by a monomial times a monomial divided by another monomial. Now, if we move this little box here, what you can see is we've color-coded them a little bit so you can best see how to divide them out. Alright, so in looking here at these, I want you to see that it's 3 times x to the 5th times y to the 3rd. Over here, you have 10 x to the 3rd times y to the 4th. Now, take a look at what I have up here and ask yourself, is there anything just like it down below? For example, look at this y to the 3rd and y to the 7th. And then also notice here, you have a y to the 4th over y to the 5th. And then notice this x to the 5th here, and then notice the x to the 2nd down there. And lastly, you can see you have x to the 3rd here and x to the 3rd up there. Those things will be dividing out. Also, look at the 2. The 2 will go into 10, and the 3 will go into 9. Alright, so let's go ahead and simplify a few of these. So, let's start dividing things out. First of all, I'm going to take the 2 and I'm going to divide it out with the 10, and that leaves me with 5. Then I'm going to take the 3 and it divides out down here, leaving me with 3. And then I'm going to divide the x to the 3rd out with the x to the 3rd. Now let's rewrite it so we can kind of see what we have here. On top, I have a 5. And let's see, I'm going to go ahead and let's put x to the 5th. And then I have y. Now notice here I have a y to the 3rd times y to the 4th, which gives me y to the 7th, all over. And on the bottom I have a 3. And I have an x to the 2nd. And I have, you know what, I'm going to write it as y to the 7th this time times y to the 5th. I'm not going to combine those. The reason why is because I see that I have a y to the 7th on top. So this will divide out with this. Now, one more little thing that will divide out. Notice I have x to the 5th here, and I have x to the 2nd down here. So with that in mind, I have like bases, so I'm going to subtract the powers, so that gives me x to the 5 minus 2, or x to the 3rd. So my final answer here is going to be 5 on top, 3 on the bottom. Let's see, I have a y to the 5th on the bottom. And on the top, since these two divide in, leaving me with 3, as I said, that gives me x to the 3rd on top. And there's my final answer. Now, a little bit of a plus when we multiply and divide. From now on, you don't need to find where it will be undefined unless I specifically tell you to. Okay, now let's take a look at division. When we look at division here, you're going to see a 3x to the third, a 3x to the fifth, y to the third up here, divided by this monomial here. But then I see division, and then I see another problem. Now, you're going to notice that this problem is much like the previous problem. Matter of fact, it's the same problem. All I've done is I've just flipped it over. So, remember with division. With division, you flip over the second piece, which is the denominator, and then you multiply. Now, I have a little saying that I like to use here. It's called KFC. We're going to keep the first one. We're going to flip the second one, and we're going to change the sign from division to multiplication. Alright, so when we're all done, the problem is going to look like this. And then from here, we're going to simplify it just like we did on the previous slide. So I see 2 goes into 10 5 times. 3 goes into 9 3 times. I see the x to the third divides out with x to the third. And then we can just continue. Let's start combining it now. So I have a 5, I have x to the fifth, and I have y to the seventh over top. And on the bottom, I have a x to the second, y to the seventh, y to the fifth. Now I can see that my y's will divide out. So these divide out here. I see that these two will divide out, leaving me with 3 up there. So my final answer, and I'm going to go right down here with it. So my final answer is going to be 5. I have x to the third over, let's not forget that 3 that's down there. We have 3 y to the fifth. And then notice, we got the same answer as I did before. So, in a nutshell, what's the difference between these two problems, between multiplication and division? Very little. The only difference is you use the KFC, keep, flip, change, and then you do the problems the same. Alright, let's see how we did. Did we get this answer correct? And yes, we did. Alright, now let's take a look at this one here. Notice I have multiplication here. Okay, so since I have multiplication, do I need to keep flip change? No, I do not. So this time, let's take a look at my numerator. Can I factor that? Well, it's x minus 3. No, you can't. So let's look at the bottom. 4x plus a 20. Can I factor that? Well, yes, we can. Matter of fact, what can I do? Well, remember, always ask yourself, is there a greatest common factor? And you're going to say, well, yes, there's a 4. If you factor out a 4, that leaves you with x plus a 5 left inside. Alright, so that's what this one factors down into. Now, let's take a look at the second one. What about this one here? Well, is there a greatest common factor? No. Is there 2 terms? Yes. Is it a difference of 2 squares? Yes, it is. X squared minus a 9. Alright, so when we factor that one's going to factor out into x minus a 3 and x plus a 3. Now let's take a look to see if there's anything here that will divide out. Well, I see up top that there's an x minus 3. And I see here there's an x minus 3 as well. Those will divide out. Now, so let's go ahead and let's cross those out. So the x minus 3 divides out with this x minus 3. Now, what else? Well, I see there is an x plus 5 and another x plus 5. So we can divide those out. So those divide out. Now, notice, everything divided out on top. So what is left on top? Well, if everything divides out, we're always left with a 1 on top. So on the top, we're going to put a 1. And on the bottom, what's left? Well, I have a 4. And then I have an x plus a 3. All right, so let's see how we did. Ta-da! We are right. Okay, so here's our answer. Okay, let's practice some more. This one, what do we see? Well, guess what? We see division. So, what's the very first thing we're going to do? Well, if you said keep flip change, you are correct. So, we're going to keep the first rational expression the same. I'm going to flip the second rational expression, and I'm going to change this division sign to a multiplication sign. All right, so here it looks just like that. All right, so now, what do we do from here? Well, now we're ready to start factoring it. So let's ask ourselves, will this factor? Well, hopefully you're going to say no. Will this factor? Yes, it will. What about this? Will this factor? Nope. Will this factor? Yes, it will. By the way, does this problem look familiar? Didn't we just do this problem? Yes, we did do it. Okay, so we're going to do this problem just like we did the other one. So you're going to end up with x minus a 3 over top of 4 times the quantity, x plus a 5, times, then I get an x plus a 5, divided by x minus 3, and x plus 3. Then we're going to start dividing things out. And I see the x minus 3 is divided out, the x plus 3 is divided out, and for our final answer, we are left with 1 over top of 4 times the quantity, x plus 3. And there's our final answer. And do we agree? Did we get it right? And yes, we did. Okay, now let's review for just a second. Let's recall something. Recall that if you divide by a fraction, it simply multiplies by its reciprocal. Okay, so just a quick refresher here. When you're dividing, it's the same as multiplying by the reciprocal. All right. Let's move on. Why don't you, before we continue on with a few of these, because we do have one more leg of the trip, why don't you pause this video, go get yourself a snack, and let's rest our hand for just a second, and then in about 5 minutes, let's come back. Go ahead and pause the video. Alrighty, now let's go ahead and take a look at this problem here. And looking at this, let's see, I have a trinomial divided by a binomial. And then I see division, that automatically tells me I have to do the KFC. And then I have a binomial divided by a trinomial. Alright, so let's apply the KFC. So we're going to take the first one, keep it the same. I'm going to take the second one, and we're going to flip it. So it's going to look like this. And and then I have to change this from division to multiplication. Okay, so that's the KFC. Now I'm ready to factor each one of these. Now at this point, why don't you pause the video, take a piece of scratch paper, and see if you can factor each one of these, and then we'll come back and see how you did. Okay, go ahead and pause it. Alright, so now that you've factored these, let's go ahead and take a look to see if you agreed with what I have. On the first one here, factored into 2x plus 1 times x minus 4, or vice versa, x minus 4 times 2x plus 1. The bottom one is pretty easy. It's just x squared minus a 9, so I can go x minus 3x plus 3, or as it has it here, x plus 3x minus 3. Now, what about the other side? Well, first of all, if you look over here, I see that I have a common factor of 4 there. So the first thing I'm going to do right here is I'm going to factor out a 4. So we're going to factor out a 4. And let's see, what else can we do on the bottom here? Well, that's a difference of 2 squares. So I can factor that, 2x minus 1, 2x plus 1, or 2x plus 1, 2x minus 1. Either way is fine. Now, let's see if we can factor any further. Can I possibly factor this one out some more? Well, it's a trinomial, so if you tree it out, hopefully you got the same thing that I did. It factored down into 2x minus 1 and then 2x minus 3. Now, from this point, you can see things are going to start to divide out. So, now notice the reds and the greens and the blues. Those things divided out, and when you were all done, you had left on top what? Well, it looks like we have a 4 and an x minus 4 on top, and so that's what we're going to have on top. And on the bottom, well, let's see, I'm left with an x plus a 3, and that looks like all that's left. Everything else got divided out. So my final answer is 4 times the quantity, x minus 4, times, or divided by x plus a 3. And there is our final answer. Alright, now let's go to this one here. This time, it's the same type of thing. However, this time, it has an equal sign in it, and it's equal to 14. Well, how do I handle this problem? Well, guys, you handle it the same way. So what you're going to do is I want you to pretend that we don't have this 14 on this side. So let's cover it up there for a second. And I want you to do this x squared minus 25 and the x minus 5 just as you did before. Alright, so you're going to go ahead and you're going to factor it. So the top factors into what? Is the difference of two squares, so x plus 5, x minus 5, divided by x minus 5. And then you see, notice here, the x minus 5 divides out with the x minus 5, leaving you with just an x plus 5 on top. And now we can take off this box and we can set it equal to 14. Now we have an equation. X plus a 5 equals 14. And then all you do from this point forward is you're going to subtract 5 to both sides. And when you subtract 5 to both sides, you're going to be left with whatever's under this box. So tell me, what's under this box? X equals 9. Yep, that's it. Alright, now make sure, don't forget, because you got a finite number of solutions, take that answer and you're going to put it in set builder notation. Now, one other thing I would recommend doing, because you want to make sure none of your answers are extraneous, take that 9 and plug it back in for x up here and simplify it to make sure it works. So let's go ahead and take that and just make sure it works. So let's see, I have 9 squared minus 25 divided by 9 minus 5. And if that gives us 14, we're good. Well, let's see, 81 minus 25, then we're going to divide by 4. Yep, that does equal 14, so we are okay. Alright, now, I want you to pause the video on this one, and I want you to work through this one, and then we'll talk about it. So go ahead and pause the video. Alright, now that you've worked through it, let's see how you did. Well, the first thing you should have done is you should have factored the top right here. And when you factored the top, it should have factored into x minus a 3 and x plus a 4. Now, this x plus 4 here, that doesn't factor. So, it's just divided by x plus 4. Now remember, currently, you're going to ignore this piece for a little while. You're going to ignore that piece. If you want to, go ahead and cover it up. Alright, now that we have divided the x plus 4s out, okay, so those x plus 4s are all divided out, and I'm left with just an x minus 3 equals negative 7. Alright, now, here we're going to solve for it, so we're going to add a 3 to both sides. So we're going to add 3 to this side, add 3 to this side, and we get x equals -4. Now, we better check our answer, because you know what? If I take this answer here and I plug it in up there, notice what happens to the denominator. -4 plus 4 is 0, and I cannot divide by a negative. So that tells me that this answer is extraneous. It does not work. So my solution is going to be the empty set. So there's no solution. All right. Here's what your homework is going to be. So save this until tomorrow when you come to class, and we're going to be working on these problems. Now please don't forget, make sure you write your summary at the end of your Cornell notes. We'll see you tomorrow. Goodbye.